Hello everyone, welcome to Unacademy. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If it has been perfect, just write perfect over the like chat and then we are going to go ahead. Let me focus over the agenda behind today's video. I'm going to take few number of numericals based on the concept of continuity, differentiability and the existence of a limit in given certain test point. Let's take, it could be a fixed point x is equals to c or it could be a certain range of x. Agreed? So I would request to each one of you, probably you must have a familiarity with the way we have been dealing, the way the quality of content is being delivered. So you can get enrolled with us. And now here comes a Pratigya batch. The classes, you yourself would be able to see each and everything. And the goal which you had to follow, and that is being GATE classes by GATE Academy. You can see Sujay sir, Gurupal sir, Sisir sir, me, Parasoni and Kavindra sir would be taking care of this complete course. You will definitely enjoy this course. There is no doubt as such. Yes, you can see very well because this was quite light, no, and it has been dark. So probably the visibility would be much better in compare with the last slide. The code which you had to use, no, the code has been GA1111. Whenever you had been using the code while getting enrolled in this particular product, definitely the code which has to be used has been capital G, capital A, 1111. If you want, I can write it over here. It has been GA1111. GA1111. There had not been any space as such. Agreed? Now the amount which you guys had to pay, it's been bare minimum. For 15 months, you had to pay just 4,499 rupees. And for 30 months, it's just been 6,499 rupees. And keep in mind, and that interface which you have been getting, no, such a great interface you have been getting. Agreed, no? And same goes the amount of content which you guys have been getting. For mechanical, it has been 777. For civil engineering, it has been 938. For electrical engineering, it has been more than 1000. And same goes with the GATE electronics, it has been 962. And for GATE CS and IT, it has been somewhere 968. And such a least amount you guys have been paying. Such a least amount you guys have been paying. Agreed? Till this point, I don't find any of the student would have any kind of doubt at least. You can have the look of it. Agreed, no? Okay then. Just a minute. There had been a certain problem. Yes. Aman, the goal itself has been quite clear. At least in global channel, our mode of communication is going to be in English actually. Mode of communication itself is going to be in English. So, but at the same time, the English which I would be using, definitely it would be well understood to all of us. To all of us. There would not be any doubt as such. So what we have been doing now? My agenda has been quite clear. In today's class, I am going to take few number of numericals based on the concept of continuity, differentiability, and limit test. So here comes the question. For each question, what I am going to do, I am going to offer approximately 2 minutes. You have to read the problem thoroughly, and from yourself, you had to give the propermost answer. For each question, I would be giving approximately 2 minutes. So let me start the timer. So I have been coming out from the digital board, and here the timer starts. Tell me, what could have been the best most answer for this given question? And you yourself would be able to see this question has been asked in GATE mechanical year of 2014. The problem was crafted by IIT KGP. Tell me what must have been the best most answer. The problem states if a function is a continuous at a certain point. Let's take a function is being found to be a continuous at a certain test point. Let's take it to be x is equals to c. The limit of function may not exist at the point. The function must be derivable at that point. The limit of the function at that point tends to infinity. The limit must exist at the point, and the value of limit should be same as the value of the function at that point. Read the problem carefully and tell me what could have been the best most answer. Aman had started giving the answer. That's great, Aman. And that's what I'm saying, Aman. My wordings are not been very, very big jargon in English. Only and only technical words which are been quite okay. Aman had given the answer, and according to the Aman, the answer has been D. Answer has been D. Anyone else apart from Aman? Correct, Aman. D has been the best most answer. So let me focus over this question and I will try to explain the thing into the better way. See what had been happening. Just try to understand. D has been the best most answer. In this question, they had been focusing the given function has to be continuous. What does it mean by the continuity? That means if you have been moving over a different values of x, nowhere the pen has been lifted, specifically at a test point. And if the pen has not been lifted, that means the worth of the function just before the test point, let's take x is equals to c, just after x is equals to c, that is been fc plus, and that too at x is equals to c, it has to be very same. We had already taken few number of examples earlier. Let me take those examples once again. So here comes the x-axis. This has been my x-axis, and let's take this has been my y-axis, and the test point has been somewhere at x is equals to c. At x is equals to c, and this has been a function over here. This has been a function over here. So tell me, at x is equals to c, function has been a continuous or discontinuous? Obviously, sir, it had been continuous. How did I know that it's been a continuous? Obviously, sir, while looking over this graph, nowhere the discontinuity has been found at x is equals to c, or graphically nowhere I had left this plane while draw this curve. I did not left my pen. But mathematically, how it has been defined? Mathematically, it has been defined if just before x is equals to c, that I call left hand limit. That has been the worth of the function is being taken as fc minus. Just after x is equals to c, the worth of the function is being taken as fc plus, has to be very same as the worth of the function at x is equals to c. So the limit do exist at a point c, provided left hand limit has to be equals to of right hand limit has to be equals to of worth of the function at x is equals to c itself. How the left hand limit is been defined? The left hand limit is been defined as limit h tends to 0, the worth of the function at c minus h. And similarly, it is been defined as limit h tends to 0, the worth of the function at f of c plus h. F of c plus h and is equals to f of c. You must have seen in last class, as far as the limit is concerned, it is nothing to do with the value at x is equals to c. It is just has to do with the worth just before x is equals to c and just after x is equals to c. If there had not been any abrupt change at x is equals to c, by default the function would have existence of the limit at x is equals to c. So one thing has been quite sure. Just try to understand in this way. If the function has been continuous, by default the limit do exist. If the function has been differentiable, it has been continuous, and at the same time the limit do exist. So previous year paper of gate, no, that is what I have been doing, no, that is what I have been doing. So till this point I don't find any of the student would have any kind of doubt. So may I know which has been the best most answer? The D has been the best most answer. D has been the best most answer. D has been the best most answer. Let's try to understand in this. Now let me focus over the remaining part. The limit of the function may not exist at a point. No, not at all. My dear friend, if the function has been found to be continuous at x is equals to c, it has to follow this three important equality. Left hand limit has to be equals to of right hand limit is equals to the worth of the function just at x is equals to c. So if it has been continuous, by default it has been satisfying the starting two equality, and if it has been satisfying starting two equality, by default the limit do exist, because for the existence of the limit at x is equals to c, the left hand limit has to be equals to of right hand limit. It is nothing to do with the worth at x is equals to c. Could you really understood what exactly I wanted to communicate? I wanted to communicate from here, if the function has been continuous, left hand limit has to be equals to a right hand limit. By default, the limit do exist. So as far as the option A is being concerned, the limit of the function may not exist. No, not at all, my dear friend. The function must be derivable at a point, not necessary. We have already seen this. Let's take an example. This has been my x-axis, and let's take this has been my y-axis. What I have been doing over here? Just a minute. Where it had gone? Yes. What I have been doing over here, just have a look of it. I had made a modular function. Let's take that function is been fx is equals to mod of x. Mod of x looks something like this, and this would be upper facing b, and let's take my point of interest is been x is equals to c. You yourself would be able to understand the function is been continuous. Function is having a limit at x is equals to c, which is been x is equals to 0. But as the cusp is been formed, what does that mean by the cusp? That means a top or valley is being formed, which is non-being smooth. And if it is non-being smooth, no, you won't be able to draw a unique tangent at this point. No, you won't be able to draw any unique at this tangent. So obviously, I will be able to say the function has been continuous, but it is not been differentiable. If I take another situation, if the function has been like this, and again the test point is been at x is equals to c. At x is equals to c, the function has been continuous and at the same time it is also been differentiable. Did you understand what I am saying? So if it has been continuous, it can or cannot be differentiable, but if it has been differentiable, by default it has to be continuous. So obviously b is also been discarded. The limit of the function at point tends to infinity. No, it can't be. It can't be at any cost. Just try to understand this way. If the test point is been at x is equals to c, and the function which we had chosen, let's take it has been 1 upon x. So you must be knowing about 1 upon x. The 1 upon x is been a rectangular hyperbola. When the x has been negative, 1 upon x would be negative. When the x has been positive, 1 upon x would be positive, and x is equals to 0. The value is simply going to be infinity, and the curve is sort of this. And if this is the curve, you yourself would be able to understand, no, it is not been having limit at x is equals to 0. Agreed? So the most answer is been D. Aman, this concept has been clear to you? If you had any kind of doubt, you can definitely raise over the live chat. So till this point, I don't find any of the students should have any kind of doubt at least. Nobody should have any kind of doubt at least. Aman, is that part clear? So here comes the next question. Again, kind of same problem. If a function is a continuous at a point, its first derivative may or may not exist always, will not exist, has a unique value. Again, the kind of question which may get raised in GATE examination for 1 mark. Definitely it won't come for the 2 marks. So it's been a theoretical understanding of continuity and differentiability. Tell me what would be the most answer. Aman, probably I may expect the answer from you, because the same concept is already been learnt earlier. Tell me, if a function has been a continuous, the function is been found to be a continuous, let's take at a test point x is equals to c. So what are the important conclusion I must have been deduced from this information? So Aman says the answer must have been may or may not exist. Obviously, we had already seen. See, if function is continuous, fc minus has to be equals to of fc plus, and that has to be equals to of fc. Or put together, I should not have withdraw my pen while drawing that curve. It has to be it has to be a continuous curve, but that curve could be smooth as well as non-smooth. If it has been smooth, you can draw a unique tangent, and as you will be able to draw a unique tangent, you will be able to find its unique slope, and obviously the function would be differentiable. If the cusp formation has been taken place, what would happen? There would not be any unique tangent which we can draw over that point, and obviously the function will be non-differentiable. So that is what we had already taken an example. Again, the same thing I have been doing over here, my dear friends. What I have been doing, just try to understand this way. This one, yes. Yeah. Let's take, this has been the x-axis, this has been the y-axis, and the function which we had taken is been mod of x. Mod of x is been upper facing v shape, and similarly I may take another function where the function is being taken as a x square. X square is been upper facing parabola. Again, this has been x-axis and y-axis. Upper facing parabola is going to be smooth everywhere. Now, my point of interest is been at x is equals to 0. At x is equals to 0, either you take function magnitude of x or modulo of x, either you take x square. Both are being continuous. How did I know about the continuity? Because I did not left this plane while draw this curve. So just by watching the curve itself, I must have told the answer has been this. Yes, no? Yes, sir. But Here the cusp has been formed, and as the cusp has been formed, you won't be able to draw the unique tangent over here, and as you will not be able to draw a unique tangent over here, you won't be able to find a unique slope at this point. And that is why you can say mod of x is been non-differentiable at your test point x is equals to 0. It is been non-differentiable. But if we'll take the reference of x square, it is been differentiable at x is equals to 0 because its unique tangent can be drawn at x is equals to 0 and which would be parallel to the x-axis. And yes, it is been differentiable. So what's the conclusion we can deduce out of it? If somebody says the function is been continuous, you won't be able to ensure whether the differentiability test would be passed or failed. You won't be able to say anything. You won't be able to say anything. Is that part clear to all of us? I don't find any of these students would have any kind of doubt now. May or may not exist. Exist always? No, not at all. Will not exist, that also I can't say. It may exist. Has a unique value? My dear friend, until and unless you won't be able to get its first derivative, how will I know about it that it would have a unique value? No. So again, B, C and D is again been ruled out. Again been ruled out. Now the next important point. Aman, this question goes to you. If a function is differentiable at a point, its continuity. May I know what would be the answer at that case? May or may not exist. Exist always, will not exist, has a unique value. So only one change had been made. The information which had been supplied to you was earlier that the function has been found to be continuous at a test point, and now it had been found to be differentiable at a test point. So may I know what's the conclusion you are going to deduce out of it? Exist always. Yes. Now another change has been taken place. Aman, the next question goes to you. What I have done? If a function is found to be continuous, then limit. So rather focusing over its derivative, now I have been focusing over the limit. May I know what must have been the answer in that case? Limit may or may not exist. Exist always, will not exist, has a unique value. Tell me. Again B. Patel Sagar, great. So just try to understand Patel as well as Aman what exactly I wanted to communicate over here. Here the three number of tests which we had conducted has been the limit test, continuity test and the differentiability test. Actually they follow the ladder structure. In ladder what happens if you had been standing at the topmost ladder, no, by default you must have gone through the first ladder, second ladder and third ladder. The first ladder has been the limit. Once the limit has been passed, you will search for the continuity. Once the continuity has been passed, you will be searching for the differentiability. So what's the important conclusion I could have got out of it? If the function has been differentiable, if you have been standing here and you have been dancing with certain song, by default you must have gone through this step, then only you have been dancing over here. What does it actually mean of it? That means if the function has been differentiable by default, it has been continuous as well as the limit do exist. Agreed. Similarly, if you have been standing at a continuity, if somebody had said the function has been continuous, somebody had said the function has been continuous. If the function has been continuous, it is not necessary it is going to be differentiable, but by default limit do exist. Yes, no. Just take an example. This has been Asia. Then comes India. And then comes, let's take CG, Chhattisgarh, from where I have been teaching you guys. Chhattisgarh. My dear friend, if you belong from Chhattisgarh, by default you have been sitting in India and by default you had been hailing from Asia. But if you have been belonging from Asia, it does not mean that you have belongs from India as well as CG. So you can say in this way, Asia has been limit, India is continuity, and CG is been differentiability. If you have been standing at CG, by default you have been part of India, by default you have been part of Asia. If you have been standing at India, By default, you have been part of Asia, but it is not necessary that you have been part of CG. You may also be in UP also. You may also be in Punjab also. Did you understand what exactly I wanted to communicate? So I don't find any of these students could have any kind of doubt. Anyways, the two students who have been watching live just wanted to uh, ask one thing. The way I had been giving examples, should I go ahead with those examples, or should I so only and only question and would be discussing about its straight solution? Aman and Patel ji, tell me. The way graphically I had been intuiting each and everything, would it be a better approach to get solved the each and individual question, or should I show the question and straight away must get the answer? Must get the answer. Not only not only exponent function, even all kind of polynomial, the function would always be continuous, would always be differentiable. If you don't understand, let me show you. See, let me go into the graph. See, here comes the function now. Here comes the function now. Let me remove few of them. Let me remove few of them. See, as you have been saying e to the power of minus x. My dear friend, e to the power of minus x, once you'll expand it, no, it has been a running polynomial. It has been 1 plus x squared divided by 2 plus x cubed divided by 3. Any of the function which can be written in form of running polynomial would always be a continuous as well as differentiable function. If you don't understand, just try to understand in this way. X, whether it's been a polynomial or not, polynomial, that means the power of x should always be a whole number. So here comes x. Let me do one thing. The x would be drawn in blue curve. What I had done, I had taken another graph which would be drawn in red, and that has been x, and then let me add that up with x square. X raised to the power of 2. Where it has been? Here it has been. X raised to the power of 2. Even if you take the higher one as well. Yes. And here comes x plus, let me copy this down. Okay. Plus x raised to the power of 3. Raised to the power of 3. Let me draw this down. The x would be drawn over the blue, then red, then. Yes. So let me go back. You yourself would be able to understand. See, blue one has been a straight line. Can you find any of the curves? No, sir. It has been completely smooth curve. Everywhere, the function is been differentiable. You can draw unique slope everywhere. And if it has been differentiable, by default, the continuity as well as the limit test gets existed. Same goes with the x plus x square. You could have taken x divided by 2 plus 3 times of x square. But one thing has been quite sure, the function has been quite smooth. And nowhere the discontinuity has been formed. The red one. Even this must have been a point where probably the differentiability test must have been failed, but it had not happened. You yourself would be able to understand. Here the slope is being smooth, and the slope is being smooth. You can draw a tangent. Aman, tangent in Hindi it's been called as a spars rekha. The rekha or a straight line which just kisses the given function, it does not crosses it. So may I know how it would be? How it would be? So let me draw this down, and here it comes like this. You can't draw like this because here the intersection has been made. But I'm saying you can't draw like this. Whether it has been tangent at this point, no sir, because it has two intersections. So only and only one unique tangent you had. And same goes with this as well. So probably this point, is it been clear? I would like to know from both of you, is this part is been clear? If you want to have e to the power of minus x, e to the power of minus x would also look same. So let me do one thing. Let me take that as well. So here comes, let me change it out. So here comes e to the power of minus x actually. Minus, and here goes x. Let me draw this down. Okay, it has not taken that. E to the power of, here goes the power part, and then comes minus of x. Minus of x. You yourself would be able to see how it would be looking like. See? Yes. Even you might have seen this factor. it had been keep decreasing, and somewhere it is trying to make a curve over here, but no, this has not been curved. If you try to understand how the tangent would look like, see, at this point the tangent is been quite smooth, and you can see a tangent has been a quite unique, quite unique. So as far as if this point, the tangent has been towards downside, it has been decreased a bit, and here the slope had become zero. See, slope had become zero, and you yourself would be able to understand everything has been. यार हिंदी में पूछ लेता हूँ एक बार, मजा आ रहा है कि नहीं? Because the global has been meant for the communicating the thing in the English. That is what I have been using the English methodology. Because many of the students who have been from southern part of our country, they have not been much acquainted with Hindi. So that is why the mode of communication has been found to be in English only. Agreed. Agreed, sir. So I think it's been the right time. I should also be following the next slide. So here comes the next question. And this question, yes. This question had come in ISC Bangalore. Although it looks very easy, but this question has been framed in ISC Bangalore in year of 1996. So here comes the next question. Here comes the next question. Anyways, this question had already come from Gate Electronics year of 2016. Again, the question was framed by IISC Bangalore, Indian Institute of Science, Bangalore. Read the problem carefully. Read the problem carefully and tell me what could have been the best most answer. Given the following statement about a function where a real number of x is been mapping to a real number of y, could you really understand what exactly I wanted to communicate? That means for all possible value of all possible real values of x, the function is already been leading or mapping the real value. If you don't understand, I think this has been the right time I should be taking few number of examples. Like. If you take a function, f of x is equals to of root over of x. For all positive value of x, definitely f of x is going to be a real number. But if you take x which is being lesser than 0, although the x belongs to the family of real number, but f of x would be belonging to the family of imaginary number. So if I say the function fx is equals to root over of x, should it be following the mapping of r over r? No, sir. No, sir. It has not been happening. This has not been happening. Or I must say, if you had two sample space, first and second, here it's been x and here it has been f of x. And let's take this has been a real number and this has been the set of real number. Should I be writing this? No, sir, I can't write this. All real number would not map to a real number. Only and only positive value of x. But here it had been clearly given that all real number of x is been mapping to the real number of x. Can I take this function? I would like to know from both of you. Can I take this function fx is equals to x square? Has it been following this requirement? Yes or no? Has it been following this requirement? Yes or no? Patel Sagar and Aman Kumar. No, this concept should also be known to all of us. What happens many of the times, if they would be focusing more over this function, no, most of us may not be able to actually know what had been given over here. Why a real cannot map real? Yes. Now here you can say, no, what I'm saying, if you take x is equals to -1, if x is being taken as -1, so function is going to be root over of -1, or root over of -1 is been iota, which has been a complex number, or virtually speaking, it has been a pure imaginary in nature. So you can see very well for the negative value of x, the mapping is not between real to real. It has been real to pure imaginary. Pure imaginary. Patel ji, bataiye, for fx is equals to x square, what has been your verdict? What has been your verdict? Fx is equals to x square. Yes, this has been the case now. This has been the case now. Fx is continuous at x is equals to 0. The function is being found continuous at x is equals to 0. Then it is also differentiable at x is equals to 0. No, this has not been the correct statement. It may or may not be. Not always. If fx is continuous at x is equals to 0, then it may not be differentiable at x is equals to 0. That's quite possible. That's quite possible. Like at x is equals to 0, if you take a function magnitude of x, which has been a real valued function, obviously frames a cusp over here. Frames a cusp over here. Yes. If fx is differentiable at x is equals to x naught, then it has been continuous at x is equals to x naught. Yes. Keep in mind, this has not been the options, they have been just statements. I had to endorse their statement by taking the 4 different options as a part of MCQ. P and Q. P is true. P is not true. A has been ruled out. P is false. Q is true. R is true. Yes. P is false. That is quite okay. True, false, no. So the B has been the best most answer. B has been the best most answer. Now I would like to know from each one of you, if I had taken a function, let's take the function is being f of x is equals to mod of x. Can I write this as a real to real mapping? Can I write this as a real to real mapping? Yes. If you feed 1, it would lead 1. If you feed -1, it would lead +1. If you feed -2, it would feed a +1 only. So I should say, let's take, this has been a set of all real numbers. And again, this has been the set of all real numbers. You will see all real numbers of x would always map to the real number of y. The real number of y. A bit problem what they do. Deliberately they have taken this, no? Because many of these students, just by watching R to R mapping, no, they must have been blown out. They must have been blown out. Okay then. So here comes the next question. Amman as well as Sagar, has it been your first class, or you guys are been attending my classes in regular basis? Tell me. So this question have been crafted in GATE Electrical Engineering by IIT Guwahati in year of 2018. Read the problem carefully and tell me what could have been the best most answer. Read the problem carefully. Let f be a real valued function. What is the actual mean of it? But for all possible values of x, f of x would always lead a real value. Fx is equals to x square. For x greater than equals to 0, fx is equals to minus x square for x lesser than 0. Which one of the following statement has been true? Which one? Aman, then what you guys have been doing here? Let fx is equals to x square for x greater than 0 and fx is equals to minus x square for x lesser than 0. And I feel this has been the point where major of the student would have doubt now. Read the problem carefully and tell me what would have been the best most answer. There are 2 methods to solve this problem out. Either you could have gone through the graphical technique, and with the help of graphical technique, within 5 to 6 seconds, you will be able to conquer this problem. And the second method is being a method of mathematics, a procedure of mathematics to be followed. Even the procedure of mathematics can also be taken in 2 different ways. Either the basic, most fundamental of differentiability test, either the alternative method. My dear friend, just try to understand in this way. What I have been doing, I have been taken xy plane. Here goes x-axis and here comes y-axis. This has been the x-axis and this has been the y-axis. The function has been written as x square for x greater than equals to 0. How the y is equals to x square used to be? Y is equals to x square used to be like this. Yes. Upper facing parabola. It's been kind of this. And similarly, fx has been minus x square for x lesser than 0. It has been lower facing parabola. Agreed? It has been clearly shown. What had been clearly shown over here? Just try to understand. Fx is x square only and only for the positive value of x, and fx is equals to minus x square only and only for the negative value of x. That means this part would be rubbed out and this part would be rubbed out. Did you really understood what exactly I wanted to communicate over here? Yes, sir, we had a little bit idea. You can go ahead now. So what I have been doing, this part is gone, and then this part is gone, and the curve has been like this. Like this and like this. What they have been talking now. Fx is continuous at x is equals to 0. Obviously, it has been continuous. Not only continuous, even the differentiability test is also existed at point. Fx is continuous but not differentiable. Who said this? Aman. It has been continuous as well as a smooth curve has been framed. Fx is differentiable, but first derivative is not continuous. Anyways, there have been several things. So yes, fx is continuous, but not differentiable. No. This has not been the case. Now, tell me. Fx is differentiable, but its first derivative is not differentiable at x is equals to 0. Tell me, what could have been the best most answer? Fx is differentiable, but its first derivative is not continuous at x is equals to 0. Tell me what could have been the best most answer. Tell me what could have been the best most answer. Just let me give you a little bit glance of it. Just try to understand in this way. I had come to my working board. Here goes x-axis, y-axis. This has been x-axis and here goes y-axis. And this has been the curve over here. See? And this has been the curve over here. Probably the both of the students might be thinking, sir, we are not able to visualize how the minus x square and plus x square would be drawn, so we won't be able to comment anything. So the best way must have been, just try to understand this way. Function which had been written as y had been written as minus of x square when the value of x is lesser than equals to 0, and had been written as x square for x greater than equals to 0. If you focus over the differentiability test, the function is said to be differentiable at any text point. Let's take here it's been x is equals to 0. If left hand derivative and right hand derivative are found to be same. Left hand derivative or right hand derivative are been found to be same, or virtually speaking, if you just go beyond x is equals to 0 and just go after x is equals to 0, once you draw the tangent, both should carry the same slope. Yes, sir. But how do I know about it? Left hand derivative, my dear friend, towards left hand side, which function is being valid? Minus x square. So you must have been taken dx minus of x square, and towards right hand side x square. Has it been same? Yes, sir. At x is equals to 0, they had been same. If you write this, it's been as a minus of 2x. This is been as a plus of 2x. And once you keep x is equals to 0, definitely both are being 0. Both are being 0. Yes or no? Both are being 0. So the function is being differentiable. But if you'll draw, this has been y. If you draw another curve, again xy plane, here comes x-axis and here goes y-axis. My dear friend, towards right hand side the slope is plus 2x, and towards left hand side the slope is minus 2x. How the plus 2x would be? It would be increasing with x with the slope of 2, and it would be decreasing. So this has been x versus y. This has been x versus y dash. This has been x versus y dash. Now probably just by watching this problem you must have been communicated the thing in the better way. Tell me whether the first derivative has been possible at x is equals to 0. Yes or no? I would like to know from each one of you whether the first derivative has been possible for the given function, this function. Yes or no? Yes, sir. And that has been the first derivative of the function at x is equals to 0. The worth is being 0. Worth of what? Slope. My dear friend, this has been the function. I had taken its first derivative and I had drawn that first derivative in the form of graph. And when the worth of the graph is being 0, the slope of the function is 0. Now if I say, what about the second derivative? If I take the second derivative, how would be the structure now? Here the slope is been minus 2 and here the slope is been plus 2. So it is going to be a signum function over here. How many of us must be able to agree at this point? How many of us? So here it is going to be minus 2 and here it is going to be plus 2. So now, if I say the given function, first derivative at x is equals to 0 has been possible, but second derivative at x is equals to 0 has been impossible. If you want, you can write somewhere. First derivative, possible. Function is been continuous, but its second derivative is not been possible. Amman, have you gone through the signaling system or not? Otherwise, leave about the signum function. Have you gone through the signum function in signal system? Otherwise, you can join our course. Such a easy package we have been giving. Definitely, you can experience my lecture as well. So now let me come back. Fx is discontinuous at x is equals to 0. No, not at all at any cost. Not at all differentiable. Fx is continuous but not differentiable at x is equals to 0. No. Fx is differentiable but its first derivative is not continuous at x is equals to 0. No, my dear friend. Its first derivative is being continuous. You yourself would be able to understand this. You yourself would be able to understand it. Its first derivative is been continuous. You can see very well there had not been leaving of the pen over the graph. No, not had happened. So obviously, if we'll focus over fx is differentiable, but its first derivative is not differentiable. Its first derivative has not been differentiable at x is equal to 0. Yes or no? So D has been the best most answer. Nobody had given the correct most answer. And that's been the beauty of this question. Did you really understood? If you could understood the concept, I want a thumbs up or at least a heart. See, such a well-designed question it has been. Yes, it has been continuous, but again, the first derivative or the derivative of the first derivative has not been possible at x is equal to 0. Okay. So let me go back into the, again, question set. So here comes the next question. And probably the student who had already attended my last class would be able to smash this problem out. And this problem had been experienced in gate mechanical year of 1995. And this has been mod of x plus 1. Mod of x plus 1 on the interval of -2 and 0. -2 and 0. It's been a continuous and differentiable. Continuous on the interval but not been differentiable. Neither continuous nor differentiable. Differentiable but not continuous. Differentiable but not continuous. So focus over this question and tell me what could have been the best most answer. Focus over this question and tell me what could have been the best most answer. If you don't have a clear-cut idea about the modular function, you can take the reference of the video which probably had been taught in the last class. But still, I will little bit discuss about the magnitude of x plus 1 and then we will try to clarify in the given closed interval -2 to 0 which kind of the function it had been. Which kind of the function it had been. Tell me. B option. Aman, let me focus over the graph given by the given. See what the modular function does. Where it has been, here it has been. What the modular function does, it talks about its magnitude. And as far as the function which has been trapped inside the modular function is being concerned, it has been a pure real number. That means it can't carry any of the complex component. That means the mod has to do only and only one thing, and that to convert the negative sign to the positive sign. Keep in mind, if you take the mod of 2 plus j, the magnitude is going to be root over of 5. But if you take mod of 1, 2, 3, value remains same. If you take the mod of -1, -2, -3, the value would just get flipped into the +1, +2, +3. What I have been doing, let me focus over x plus 1. How the x plus 1 looks like. So let me focus over the y is equals to x plus 1. What I would do, I would try to get the intersection of this straight line over the x-axis and y-axis. This has been the x-axis and here comes the y-axis. At x-axis, the value of y has been found to be 0 and similarly at y-axis, the value of x has been found to be 0. How so? Until and unless you do not move forward towards right hand side or left hand side, the value of x would not be increasing, not been decreasing. So obviously over the y-axis, the value of x has been 0 and same goes with the x-axis because neither you have gone up, neither you have gone down. So the value of y has been simply 0. The value of y has been simply 0. Obviously, sir. Till this point, I don't find any of these students would have any kind of doubt now. So if I feed x is equals to 0, the value of y has been known, that has been 1. So it has been 0, 1. And similarly, when you feed y is equals to 0, the value of x has been found to be -1 and 0. So the intersection points are being 0, 1. That has been at y-axis upside and it has been -1, 0 towards downside. So this has been the structure now. This has been the structure now. My dear friend, you might have seen at x is equals to minus towards right hand side, the function has been lying towards upside. That means they were positive, and as they have been positive, magnitude is nothing to do with that. This is nothing to do with that. Nothing is to do with that. But here towards downside, what had happened? Now the value of x plus 1 is been trying to go towards downside. This has been the curve of x plus 1. No, probably x plus 1 might be going towards negative side, but magnitude would it change it to the positive. So what had been happening, just if we'll try to understand, this curve would remain as it is, but here the cusp would be framed. The cusp would be framed. And my point of observation has been in between x is equals to minus 2, which has been a vertical line at x is equals to minus 2. And this has been x is equals to 0. So may I know which kind of function it had been? Obviously, everywhere it has been continuous, differentiable, limit do exist, except x is equals to the change point. And the change point has been minus 1. Now, continuous and differentiable? No. Because at x is equals to minus 1, it has been continuous but not differentiable. Continuous on the interval but not differentiable at all points. Yes. B has been the answer. You can forget about C and D. You can forget about C and D. Kristenpal Lonkar, what have you been doing here? No. This mistake is not at all been allowed. I would like to know from each one of you which topic I should be taking in next. I can take any of the topic, whichever you want. But I want at least strength at that moment of point. Agreed, no? Anyways, there had not been any absolute function over here. There must have been, I must have been shown how it would look like actually. Graph. Yes, let me draw this down. I have taken x plus 1. So here comes x plus 1. X plus 1, 1, x plus 1. And let me add once again. And here goes minus of x plus 1. Where the plus is been. Where the plus is been. Yes. Yes, let me draw this down. So here goes the curve now. Here goes the curve now. See? This has been x plus 1 and this has been the minus x plus 1. And the curve would look something like this. The curve would look something like this. Yes. This one. Like this. Agreed? No? This has been the curve of magnitude of x plus 1. Magnitude of x plus 1. And my point of interest has been in between minus 2 to plus 1. So minus 2 has been coming somewhere here. So it comes minus 1. So this has been minus 2. And this has been 0. And obviously, in between, there had been the formation of cusp. Signum function, the trigonometric limit. Aman, I would like to know from you actually. You have been preparing for which particular examination? So I should have a little bit idea, no? So the student who have been following me have been following from which category? Again, this has been a quite commendable question. See, so far we were able to almost smash all kind of the problem graphically, but sometime drawing a graph won't be that easy. So mathematically also we had to smash the problem out. Read the problem carefully, and this question have been asked in GATE Civil Engineering year of 2011. Read the problem carefully and tell me what must have been the best most answer. Read the problem carefully. What should be the value of lambda such that the function defined below is continuous at x is equals to lambda pi by 2? Function has to be continuous. What has been said? The function has to be continuous. Function has to be continuous. Function has to be continuous. What must be the value of lambda over there? My dear friend, one thing has been quite sure as far as this problem is being concerned, the function would be called of a continuous function if the pen had not been lifted at x is equals to c, where the c is been pi by 2. That has been the test point. What does it actually mean of it? At x is equals to c, just after c and just before c, the worth of the function must be same, or I should say left hand limit fc plus fc minus, right hand limit fc plus, and even the worth of the function at fc has to be very same, and this value has been clearly given, that has been 1 actually. So for the better understanding, I could have taken the exact value of test point, and that has been pi by 2 actually. Pi by 2 minus, and here goes pi by 2 plus, pi by 2 plus, and here comes f of pi by 2. F of pi by 2 has been clearly known to be 1. Clearly known to be 1. Clearly known to be 1. So my basic intention is to create the left hand limit and right hand limit same, and at the same time this should also have their left hand limit is equals to right hand limit as 1. I had to come back over here. See, this has been a function which has been clearly defined at x is equals to pi by 2, and except pi by 2, this has been the function which will give you the value or the worth. So may I know pi by 2 minus and pi by 2 plus, should I be asking the worth of the function from 1, or should I be function with lambda cos x divided by pi by 2 minus of x? Obviously from the first, because it has been defined everywhere apart from pi by 2, and pi by 2 minus and pi by 2 plus is definitely is been apart from pi by 2. It's been apart from pi by 2. Did you understand what I'm saying? Anyways, you could have already seen which kind of effort we put over here. Which kind of effort we put over here. See, pi by 2 minus, this is been limit h tends to 0, worth of the function pi by 2 minus of h. Yes or no? This kind of calculation we do. Why do so? If we'll feed h is been tending towards 0, the f would just be retained before pi by 2. If it has been a very small value, very small positive value, the worth of the function is being calculated just before pi by 2. Just before pi by 2. Agreed? No? So I think the x has to be placed with pi by 2. That we'll be doing now. So here it becomes lambda cos x would be placed with pi by 2 minus of x, minus of x would again be placed with pi by 2 minus of h. H it has been actually. H it has been. Just a minute. Yes, h it has been. H. It has been h actually. It has been h. And then we will feed limit h tends to 0. So pi by 2 goes out, and here it would be just h. And cos pi by 2 minus of theta, that is been sine of theta. So here it becomes lambda sine of h. And here it goes limit h tends to 0. And probably you know how to get this value, and that has been L'Hospital rule. That has been L'Hospital rule. And once you'll be applying the L'Hospital rule 0 by 0, that has been, see, differentiation of sign that would make cos h becomes 1. And once you'll feed h is equals to 0, it's just been lambda. So left hand limit has been lambda. My dear friend, so once you'll calculate this, it has been lambda. It has been lambda. And this has already been known to be 1. So they had been asking about the value of lambda, and the lambda has been there in front of you. And that has been 1. That has been 1. So I think this is all about today's class. I would request to each one of you, if you guys wanted to have our helping hand, you can join our Pratigya batch. So we will try to cater over all of the expertise just for your well-being of your future. Sujay sir, Gurupal sir, Mayank sir, Pawan sir, Kavindra sir, Paras sir, and me. Definitely will be taking care of each and everything. We'll be taking care of each and everything. So how was the class? At least for the student who have been attending my class first time, how was the class? Yes, the pricing has also been there in front of you. Pricing. I can say it's been an unbeatable pricing. In future, nobody can sustain in such a I should say small amount of payment. So in future, I would say this cost is going to increase. Definitely you can get enrolled. Okay then. This is all about the today's class. Till then, bye bye. Take care.